Hi friends, welcome to Civil Engineering and Programming channel. In this video, I will show you a demo on design of retaining wall, cantilever retaining wall. Okay, just click, then just you select cantilever wall. Just then after select this, press on this cantilever retaining wall push button. Then you will get a user interface like this. You can see all these are inputs. Before that, let me explain you little bit of theory. Okay, just you click on theory, just you click on these different types of retaining walls. Okay, what is meant by retaining wall? Retaining walls are built to retain filled earth of greater height. Okay, they are commonly used in rail and road projects where earth fillings is required to maintain track, or road projects where earth filling is required to maintain track or road level, especially in approaches to bridges. Okay, in buildings also, if basements are provided, retaining walls are required. Okay, wing walls and abutments in bridges are also acting as retaining walls. Okay, you can see here, this is the typical retaining wall structure. Okay, this is the cross section of the typical retaining wall. Okay, this is nothing but backfill. We have to retain this backfill by constructing this type of structure, okay, called retaining wall. Okay, there are many types of retaining walls, but present in practice there are two abundantly retaining walls are there. One is a cantilever retaining wall. You can see here this retaining wall acts like a cantilever. Therefore this retaining wall is called as cantilever retaining wall. You can see here there are three parts. One is the stem, other is the heel slab, another is toe slab. Okay, coming to counterfoot retaining wall, this counterfoot looks like looks like cantilever retaining wall, but extra they provided the counterforts. These counterforts are very useful to reduce the bending moments developed due to the lateral active earth pressure on the retaining wall. Okay, and the retaining wall. Okay, these counterfoot retaining walls are economical if backfill is more than 7 meters. If the backfill is more than 7 meters or 8 meters, this is economical. Okay, this cantilever retaining wall is economical up to only the backfill is 6 meters. Okay, 6 meters. Okay, then you can earth pressure theories. You can see here, this is okay, different conditions for retaining wall. You can see here I have taken the three conditions. One is active earth pressure on stem if backfill is horizontal, active earth pressure on stem if backfill is horizontal with surcharge, and third condition is active earth pressure on stem if backfill is having some sloping. Okay, and this Ka is coefficient of lateral earth pressure, active earth pressure, that is K is equal to 1 minus sine phi by 1 plus sine phi, where phi is nothing but angle of internal friction. Okay, angle of internal friction of the particular soil, and Kp is equal to reciprocal of 1 by Ka. What is Kp? Kp is nothing but coefficient of passive earth pressure. Okay, coefficient of passive earth pressure. And this K dash is also the coefficient of lateral earth pressure, active earth pressure, for if the backfill is making some slope with this horizontal. Okay, then the formula is like this. You can see cos slope angle into cos slope angle minus cos square slope angle minus cos square phi by cos slope angle plus root of cos square slope angle minus cos square phi. Okay, if you put the slope angle as 0, then we'll get 1 minus sine phi by 1 plus sine phi. Okay. Okay, then stability of the retaining wall. Okay, in retaining walls, it is not sufficient if you design the sections of various parts for moments and shear. It is necessary to check the retaining wall for following two types of failures. One is the overturning about toe. Okay, let us say this is the toe. Okay, this is the toe. Overturning will take place sometimes, so we have to design such that overturning should not be there in the retaining walls. Okay, you can see the earth pressure on the stem causes overturning moment about toe. The weight of backfill earth surcharge sulfate of retaining wall will cause stabilizing movement about the toe. Hence the factor of safety against overturning is given by, you can see here, this is the factor of safety against overturning for the retaining wall is ms by m nod, where m nod is the overturning moment about toe and ms is the stabilizing moment about toe. Okay, a minimum factor of safety 1.4 is to be used as per IS 456-2000. Only 0.9 times the characteristic dead load shall be taken into consideration. Okay, this is f naught is equal to 0.9 into ms by m naught. Similarly, we have to check sliding also, whether this retaining wall will slide or not. Okay, and this factor of safety against sliding is equal to 0.9 into mu, where mu is nothing but coefficient of friction of that okay, coefficient of friction into weight. Okay, W is the total download load, download load, okay, downward load by pH. pH is nothing but active earth pressure or the horizontal earth pressure acting on the particular wall. Okay, then we have to check for shear also. Okay, shear key, shear. Okay, if this fs, okay, factor of safety, if factor of safety is less than 1.4, then we have to go for shear key. Okay, this is all about theory. Okay, this is all about theory. Then we go for you can see here, you can click here, different Ka values. You can see here values of phi, that is angle of internal friction for cohesionless soils. You can see this is material and this is the 5 degrees. This is angle of internal friction. Sandy gravel and compact sand, loose sand, shale filling, rock filling, ashes, broken brick, all these are different values for different types of materials. That is internal friction. Okay, angle of internal friction of particular soil. Then you can see here you will get Ka and coefficient of active earth pressure and coefficient of passive earth pressure. Just by click you can see here for different angle of internal friction, then you will get different values of active, coefficient of active earth pressure and coefficient of passive earth pressure. Okay, you can see here. Then you close this, and this is little bit about design steps, how we have to follow design steps involved in cantilever retaining wall. Okay, all these are parameters. First we have to design the preliminary dimensions of the retaining wall. Then after these are the preliminary dimensions: base width, toe projection, thickness, okay, and top width. Then we have to check against overturning and sliding. Then after we have to calculate pressure under the base slab due to the earth pressure. Then design of stem, design of toe slab, design of heel slab, design of shear key, optional. Okay, optional. If the sliding fails, then we have to provide this design of shear key. Okay, this is all about a little theory. Then coming to, okay, let us okay, once again. Okay, just you click on this retaining walls. Okay, then you can see note: enter the input values only in the yellow boxes. Just you type 25 grade of concrete, and grade of steel is 415, and SPC of the soil is 200, and the height of the retaining wall at this portion where the wall should retain, at what height the wall retain the soil, that is 3.5. I'm taking 3.5. Angle of internal friction of particular soil is 30 degrees. Then unit weight of the soil is 18 kilonewton per meter square, and the coefficient of friction of the particular this concrete, this wall, is 0.5, and main bar of the stem reinforcement, that is I'm taking 10, and distribution bar reinforcement of this particular stem, this is nothing but stem, that is 8. Then main bar of toe slab I am taking as 10. Okay, main bar of heel slab I am taking as a 10 mm bar. Okay, select type of stem. Okay, your stem will be uniform or non-uniform. If uniform, just you type 1. Okay, just then start design. You can see here retaining wall is safe in overturning. Okay, retaining wall is not safe in sliding, so provide the shear key. See, design is safe. Then thickness of the base slab, what we have provided, the thickness of the base slab is sufficient. Okay, then we can see here, this is all about detailing diagram of the retaining wall. You can see here. Hmm? The thickness of the base slab is 0.39 meters, and the length of this heel portion is 1.32 meters, and thickness of the stem is 0.3 meters, and length of this toe projection is 0.74 meters. Depth of the foundation is 1.21 meters. 1.21 meters. Okay, we got everything. Okay, we got everything for, and we have to provide the main bar reinforcement. Okay, in the stem is 10 mm at the rate of 157 mm, and the distribution reinforcement we have to provide 8 mm at the rate of 215 mm center to center. Okay, in the toes, in the heel slab, we have to provide the reinforcement as 10 mm 10 mm 168 at the rate of 168 mm center to center. Okay, similarly in the toe slab we have to provide 10 mm at the rate of 168 mm center to center. Okay, and the base width of this slab, okay, this cantilever slab is 2.45 meters. Okay, this is the stem reinforcement longitudinal view. Okay, we have to provide like this. We have to curtail the bars like this of 4.32 by 2. Okay, 3, sorry, 4.32 by 3 parts. Okay, then we have to write here 1 meter, 1 meter, something like that. Okay, then if you want to clear all this this particular portion, just you just type here clear. So everything is vanished. Suppose I want non-uniform stem, means like this, non-uniform stem. Then what you have to, just you type 2, and just you click on this start design. Retaining wall is not safe in sliding, to provide the shear key. Okay, retaining wall is safe in overturning. Okay, no problem. Design is safe, and the thickness of the base slab is sufficient. Okay, see, we got now the bar, the stem is tampered. At the top it is 200 mm, at the bottom it will be 0.39 meters. Due to some technical problem, it is not visible here. Okay, maybe some problem will be in coding. Okay, this is all about the design of cantilever retaining wall. Okay, anyway, thank you for watching this video. Thank you.